Hey guys, what's up? Eddie Alho here with KissAnalog.com. I'm kind of falling back into my bench here. We're going to test this little guy. This little guy came with the Class T amplifier. What is this? 230 watts. I think I called it 250. 230 by 230 watts. We're going to see how well this guy tracks. These little coupling boards, they're meant to isolate the signals, but we want them to be phased correctly, and we want them to disconnecting my stuff, but we want them to be phased correctly, and we want them to be flat across the frequency band. So we're gonna set it up, test it on the scope. We got the THD meter. We're gonna also see if this guy puts out any noise. All right. Hey, thanks guys. Let's get to it. Okay, so I've made this table, and we're gonna check the inductance. This meter allows us to change the frequency. I'm at 10K, 100K. I'm gonna start at 100 hertz and go up to 100 kilohertz. We're gonna check the inductance just to see, how the inductance changes on this core. On these, now, let's see. I'll bring this up a little closer so you can get a good look, in case you didn't see it last video. There's two isolation transformers, two transformers here, and this side says ground A, left, right, and if I turn this up, it says ground B, right, left. So the right side here, and this is A and B, and left side A and B, and pretty simple board. Alright, so let's start at, now what I've done here is I've done right A, so this A side and B side, so right A and right B, and left A and left B. So let's start there. Okay, right 5.7 I'm going to say. So 5.7 henries. Okay, off. And this meter is auto ranging 5.6. It actually, so it's almost the same on both sides. I don't think I'm going to write Henry every time. I'm just going to write the numbers down. So it'll automatically decide whether it's capacitance, inductance, or resistance. Okay, wow, 2 henries. Huh, that's interesting. Let's try the other side. $1.99. Okay, I'm going to call that 2. Wow, I thought they'd be the same. So 2 and 2 henries. A little cleaner if I don't write Henry every time. Go to 120. I'll try to pick up the pace here. I'll probably just speed through this and not make you watch all this. They definitely did not match these guys. 2.1. What I'm assuming, one guess I would make is that I'm sure they wind the same number of turns and all that stuff. My guess is they might be getting different magnetic materials. They maybe don't have a good, 20% changes is expected. Okay, 4. So they are dropping. It kind of went up and now it's dropping, so interesting. It kind of took a dip and now it's going back up again. Let's go back this side. This went up 50%. This one went up like, geez, like a bunch. About over this, I think. Whoa, now they're kind of lining up. This one's going to be around 35. Well, this is not what I would have thought. I guess that's why we measure, because we learn things. I'm really interested. I want to really get a frequency in here and see what it looks like on the scope. Oh, before we do that, let's just read the resistance. See, there's capacitance, resistance. There's RP. Okay, I'm gonna go back there. Shoot, there we go. Okay, let's just try that. I'll try 100K. I'm not sure it's gonna change with frequency, because I should just be reading the DC resistance. You know what? We're going to bring in the Astro for resistance. I want to see what the DC resistance, so this is how we're going to do it. Okay, 73 ohms. Doesn't surprise me it's high, because these are small and they're meant for signal, not power. Whoa, it's different, so there might be a different turns ratio. I'm going to say that's 91. It's almost 91. Let's go back here again. And 73. Wow. Okay, so I'm going to say this is 73.91. This is R. This is DC resistance. Okay, 74. I'm going to round that up to 74. And 91 again. Well, at least that was... See, I think that tells me that they used the same amount of turns on the same kind of wire. And the thing that's probably different is the core. They could have also put a gap in the core. When you put a gap in the core, it keeps them from saturating. But just a small difference in gap can change the inductance widely. So, not sure what they did, and I don't want to tear down my transformers and ruin them to find out, or have to rebuild them. So, I want to put a frequency on and see what that does. So, here, let me hook up the meter. I'll be back. All right, what I want to do is show you how I hook this up. This is the A side and the B side. So this is my input side. I'm going to just use A as input and inject a sine wave in the A side, and we're going to look at the B side and see if we get the same voltage out. Also in the same phase, you know, so if the sine's going up on this side, the sine's going up on this side. So we want to make sure our phasing is correct. So what I've done is I've put the signal generator right here, these two alligator, or these little clips here, and the center lead is the return, and the outside leg is the input. That's the way it's marked, right and ground. So that's where I hooked it up, and the scope is hooked up to the same polarity. And what's nice about this kind of circuit is that we're generating the circuit in with our generator, and this return is tied to earth ground, but this is isolated, so it's okay for the scope to be tied wherever we want to. So that's just a little tip there in case you're worried about, you know, hooking these grounds at the same point. I put a video together on safety talking about that. Now with our instrumentation connected to our board, we're going to start with phase checking. We're going to see if the transformer phases are correct. So we're going to start with 1 kilohertz. Go 1 kilohertz, and it's in sine wave mode, and amplitude, I'm going to go 2 volts peak to peak. 2 volts peak to peak. Alright, now what I've done, I've also hooked up the Keithley THD meter to the output, so we can see what the THD is at the output. Now, okay, what I'm going to do is I'm just going to hit the auto setup. Wow. Okay, so that is not in phase. Huh, that is interesting. I would have expected the output to be in phase with the input. When we check channel, the left channel, they have the same transformer, so I think we're going to see the same amount of phase connection, which I guess is okay if both phases are both out of phase, or you can just connect them up in reverse on both sides and put them in phase with your input. But let's just make sure the output, well, okay, before we check the phase, since we're connected to the right side, let's go through some frequencies and see what the THD is. Okay, let's start off at 20 Hertz. Okay, right now I am at 1 kilohertz and the THD is 0.00, and it's going between 4 and 5. One interesting thing to note is this Siglent SDG810 generator is spec'd at I think it's 0.2% THD. So this is reading much better than that. And I suppose this thing is spec'd at peak amplitude, and we're only putting out 2 volts peak to peak, so I'm wondering if that's why we're getting a better THD out of the generator, because I wasn't expecting to see that low of a THD on the output. Well, you know what, let me just move it real quickly to the input just to make sure. I don't know, can you see that THD up there? Alright, so I think you can see the THD now. What I'm going to do is I'm just going to move those leads to the input and verify that it's either the same or not any worse. 0.005 or 6, yeah, it's kind of jumping around 6, 7. So yeah, it looks like it's the same on the input, which again, I'm really surprised that it's, actually impressed that it's so low. Might have to send in a note to Siglent and ask them about their specifications, and or maybe I'll have to test it at full load. You know, maybe that's what I should do, is do a little video on the Siglent generator and test it out at a max output and see if it does drop down. Alright, so there it is at 1 kilohertz. Now let's drop down to 20 Hertz. We're just gonna try a couple points, and then we're gonna sweep this waveform and see how level the output is, because we want that transformer, and we want the output to be level all the way across the. Okay, I'm gonna change this to 20 Hertz. Alright, let me zoom the camera out so we can go back to the scope. Well, I'll leave it over here so we can see the distortion as well. I'm going to do this to make it easy. Hit auto setup. Whoa, and that looks horrible. Wow, that's not what we want to see. We want to see a sine wave. This transformer looks like this. By the way, the yellow's the input, and I put the purple on the output. It's out of phase for one thing. Let me switch leads around to put them in phase, and I will be right back. And instead of taking the time to switch all the leads around, I'm just going to go to channel 2 and let the I'm looking for the page 2, I guess, invert off. Let's turn it on. So we just let the scope do it for me. That way it just saves me some time from hooking up all the wires again, the test probes. So what we see is the sine wave on the yellow coming up, and as it hits peak, it looks like the transformer maybe saturates, and it drops down, and then it finishes the sine wave, and then it does the same thing on the minus side. And the output, it's not tracking at all through here, so I'm wondering if even through here it's saturated. And then as it crosses 0, the magnetic field collapses, and then it's building up again. So then the purple comes up, the output comes up, and as the transformer saturates, there's no coupling, so it drops down to 0, actually drops below. And same thing, as it crosses 0, the yellow crosses 0, the magnetic field has built up and actually saturated the core. And then as it crosses 0, it changes polarity in the core and starts to build up a field again until it saturates again. That's pretty interesting to see, kind of cool, but not so cool that it's doing it at our audio frequency. So, alright, 20 Hertz is not so great. By the way, can you see the THD is 1.3, which you'd expect it to be something bad with that going on. Okay, so what we're going to do is go to 30 Hertz. Let's just see. Maybe I should Well, we'll go to 30 since I started typing it in. Alright, well, not much better. Maybe a little bit, but not much. Still 1.3. So let's go 50. Well, I'm going to go 40. I want to, because that did change a little bit. Wow, yeah, that's looking better. But still, you can kind of see that when the yellow crosses the 0, that it kind of recovers and the purple starts to follow. I mean, it's a cool phenomenon with the transformer, but it's not cool that it's doing this. Let's go to 50 hertz. Alright, that looks much better. Although there is some phase shift still. You see how the purple is lagging behind the yellow? Well, and actually there's still some distortion. And over here we can see it's 0.83. So yeah, that's evident with the eyeball, but also the meters telling us that it's not so great. Let's go to 60. I just wanted to see how long it takes for this thing to straighten itself out. Literally. Okay, it's 0.64. Still looking better, but not so good. And we're 70 hertz now. Now we're at 70. I was hoping it'd come in. Okay, let's go to 80. Jeez. Okay, I'm gonna just, and we're at 0.5. I'm gonna jump to 100. Okay, 0.43. So there is some distortion, and it's still lagging. You can see how the purple is lagging behind the yellow. Yellow crosses, and then the purple crosses. Okay, I'm gonna go to 200. Wow, okay, now that looks a lot better. And distortion's 0.16. Okay, 0.16, that's I think acceptable probably. I'm sure some people, a lot of people, it's not. It probably really is getting to be where it's gonna be okay. That's 200 hertz. Let's go to 300. Okay, we know at 1 kilohertz it's really good. So somewhere between 300, kilohertz or 300 hertz and 1 kilohertz, we're going to see a big improvement. Right now it's 0.06, 0.07. So we're going to go to 500. Okay, now we're 0.017. I'm going to go to in between 500. I'm going to do 750, just in between that 1K. Okay, 0.002. Okay, so somewhere after 500 hertz, after 500 hertz, it's looking pretty darn good, I think. And at 1K it looked good. Let's go to 2K. That's looking, that's 0.008. Now one thing I want to point out, I'm sorry, I should have pointed out earlier, but the voltage I put in was 2 volts peak to peak over here off the generator, and right here it's saying 2 volts. Well, 2.06. Wonder if you can see that. Let me zoom in on that. You know what? I'm going to leave the camera here, and I'll read out the THD and change the frequency. That way you can see the voltage I'm putting in is right here, the peak to peak, and this is the RMS, which is what it should be. We want to make sure that the transformer doesn't load down the generator, and we want to make sure the generator is flat through the frequency range, and the output is 2.02. So it looks very flat right now. That's pretty darn close. Not much loss across transformer. Okay, that's at 2K. Let's go back to 1K. Let's just take a quick look. It looks like it's tracking pretty darn good. I'll drop down to 200 hertz, and then we'll go back up again. Yeah, it's tracking pretty darn good. The output's actually slightly higher than the input, but that's where we're starting to get. We're at 1.65% distortion, so maybe that's 0.165. So maybe that's due to part of that. Okay, I'm gonna go to 5 kilohertz. The amplitude looks pretty darn good. And we're at 0.01, so actually the distortion went up a little bit. 10K, I'll go to 20K. See if it gets worse. 0.01 still. You know, the amplitude looks like it's following pretty darn well. Now what I'm going to do is I'm going to put the generator in a sweep mode so we can sweep between 20 Hertz and, well, you know what? I'm sorry, before I do that, I'm at 20 kilohertz. Let's go to 50 kilohertz. I'm just curious. Wow, that still looks pretty good. Well, okay, actually, not sure. For one thing, the THD, come over here and show you what that's doing. It says overflow, 50 kilohertz. Oh, I wonder, maybe it can't go, I don't know what the frequency band is on the THD actually, sorry about that. Don't know, I just picked up this meter for these videos, so I don't know it very well. I'm at 30, maybe it's only good for 20 kilohertz. Oh, yeah, maybe this is designed around the audio spectrum. Sorry, we're experimenting here instead of working on our transformer. Let's get back to that. Okay, I'm going to set up the sweep. Well, if you want to see how I do that, okay, so what we do here is we hit the sweep button. It's kind of intuitive, you just have to look at it. Here's a start frequency, and I go 20 Hertz, and then a stop frequency at 20 kilohertz. Alright, and then what I do is sweep time. I can play with that and put in different times. Right now I just want to go back to the scope and show you what's going on there. Okay. Now the one thing we've already noted is at least the discrete steps that we did across the frequency band, that the amplitude seemed to track at those discrete stops across. But that's kind of what we're doing with the sweep thing, is we want to verify that. Yeah, I think at that time step I am at 200 microseconds per division. It's catching a high frequency and low frequency, I think. That sweep time, it's at 1 second. I can go to 5 seconds and see what that looks like. And what we want to do is we want to make sure that amplitude doesn't change. And you know, you can eyeball this, but just looking at this, it looks like these two numbers here are tracking pretty darn well. So that transformer, the one thing about isolation transformers or coupling transformers is that you want to have them pretty flat across the frequency spectrum of interest, and in this case our audio, 20 Hertz to 20 kilohertz. This seemed like under 500 Hertz wasn't doing so well as far as THD, so this would not be good for our bass. Now the use of this isolation transformer, I'm not really sure. Like I said, I don't have the documentation on this. I would think we could go straight into the input of the amplifier without this transformer. I thought well, I'm going to look into this and I'll get back to you on that, but we will test the amplifier both ways. So there we go, there's a sweep. I guess we've tested out this transformer. Next thing to do is hook it into our circuit and do it. And I think this video is kind of long, so we'll do that next one. Hey, thanks for watching, guys. If you like these videos, if you're interested in seeing more of this amplifier, you have some ideas what you'd like me to do, give me a thumbs up. Give me a thumbs up and leave some comments. Tell me what you'd like to see. If you'd like to see more or less of me messing around with the equipment, tell me what you'd like to see and I'll try to adjust for that. Thanks for watching, guys.